I'm the one who have to put you on. Waiting for Aaron to give me the control panel here.
Okay, we are live.
There we go. So yeah, welcome to the third community meetup for Akka.net. And with us today we have Bartosz, who's going to talk about Akka.Cluster.Sharding, and Nathan Vivo is going to talk about even. And I guess you're first out, Nathan. Can you tell us a little bit about even?
Okay, thank you. Let me share my screen here. Okay, can you see my screen?
Yep.
Okay, my name is Nathan. I'm from Brazil, and I'll talk a little bit about even. Even is a project that I created to play around with some ideas about event sourcing using Akka.net. So what exactly is even? So even is an event sourcing application framework. The idea is to give applications an entire framework that you can build, that you can use to build. And the idea is that it uses actors for all the components. All the subsystems of the framework uses Akka actors. And it supports internal and external projections. And I think I need to explain a little bit about projections here. When I started to play around with event sourcing using Akka, I started with Akka Persistence. And the first thing that I noticed was that reading data from the database after you store that was really hard. It's easy when you talk about single actors, but when you talk about events in an application scale, talking about all the events that happen, it was quite hard. So I started to build even to deal with that problem of reading information out of the database in a structured way. So projections are basically the way you use to query information from even. Okay, I think that most of the event sourcing systems out there, like Get Event Store or An Event Store, they use some kind of projections, right? And even is heavily based on Get Event Store, on Greg Young's Get Event Store, where you have projections based on a query that you do over all the streams, and you can filter out events and build whatever you want with those events. Okay, and the idea here is that even can support Akka actors as projections, and it can also support external databases as projections. And that means you can export information from even to SQL Server, MySQL, or a NoSQL database, or even a distributed database.
Can I ask you about that?
Okay, go ahead.
Can you do denormalization of data if, let's say, you're building a CQRS type of system and you want to denormalize data for a read model? Would you use that data export to do that?
Yes. The way that projections work, and I will give a deeper explanation later about how it works, but the basic idea is that you have a component that is guaranteed to receive the events you requested in a specific order. And after that, there is a lot of models that you can apply, and the idea is that even provides you with that model to denormalize data any way you want. So, for example, you could ask, imagine an application that you have a list of events like products created. You have a store and you are adding products to the store, okay? So you have a list of products that were added. So the events were like product added, and price changed, or whatever. once you create a projection to query those events, you can produce like a list of products. You could produce the number of products per category, or whatever you want. You could produce like the number of sales per day for each product. So you could denormalize this data in any way you want. And the idea is to make it easy to do that with even. Okay? Did I answer your question? Okay.
Yeah, absolutely.
Okay, so now I will just give a little explanation about the difference between even and Akka Persistence, because I see that a lot of people asked about that in the Gitter chat. So even is not exactly competing with Akka Persistence. Even is a different thing, and so Akka Persistence is part of the Akka model. It's made to be used inside your application when you are already using actor. So the idea is that you are persisting actor state, right? You can apply event sourcing to actors. You can save events that lead to a new to the restoration of the actor state when the system is restored. But Akka Persistence was, I don't think it was thought as a way to do event sourcing. It was adapted to that. I know that there's some story there about the event sourced component, but when you look at even at Akka Persistence, you see that Akka Persistence is very focused on maintaining actor state, while even is not focused on actors, but is focused on events and application state. So I'm not concerned about each actor, and actually you can build an event sourcing without any actors. Like you are not restoring actor state, but you are only working with events. For example, imagine you only want to log information to the database. You could treat this log as a series of events that happened. You don't have to restore state about that. And this was one of my concerns when building even. I wanted to, I work with a lot of business applications that we want to track data. So we want to know when a user did something in a website, or when something happened, like an email was received, or another system sends a message, and we want to track this information to do something with that later. And a lot of things in even was built to deal with this kind of thing. You don't have to have actors to work with events. Even is a framework to work with events and not actors. So I'm just trying to make this clear, because this is a huge difference between Akka Persistence and even. And because of that, it was built from the ground up to apply event sourcing to the entire application and not only to a specific component. And the difference is because when you have an application that uses event sourcing, you are more worried about what happened before or after something, not only at the actor level, but at the application level. So I want to know if a user was created before or after a product was added, or something like that. So even keeps a state, even keeps ordering of all the events in the application, and it needs to keep this ordering of events for all the streams, not only inside a specific stream. Okay?
Yeah, we got a question here from the community. Bob Brieselman asks, what do you mean when you use the term projection? Can you elaborate a little bit on that?
Okay, yeah. I will do a demo here showing how projections work, but I should probably have a slide here with some images to show that. The thing is, in an event sourcing framework, or better, in an event sourcing architecture, your database is just a series of events. So instead of storing the state of your application, you store only the events that lead to that state. And that means that you don't have a lot of tables. There is basically a single table that stores your entire application, and these tables this table is the events table. The events table is just a series of streams. Okay, strings you can think like a group of events, and you basically have this to read this string to know how your application is. So again, imagine you have a store, a physical store. You don't have any paper describing the actual state of the store. You know that you bought a lot of products, you know that you sold a lot of products, and the state is the result of all the selling and buying. So a projection in that sense is the reading of all those events and creating something that you can read and that you can process. For example, the list of products that your store have. So instead of having a table that shows you like product, you have all the information in this table, the event store only have the events like product added, product removed, product sold, or product change, or something like that. You have only this list of events. And the projection is that you read those events and you imagine a service that keeps reading those events and building these lists for you. And actually, the list is only one thing that you can do with projections, but you can project anything. Like if you read a list of sales, you can project the number of sales per day or the most sold products in the store. So that's the idea of the projection. It's the result you have when you read certain events from the store and you organize those events or extract the information from those events in a specific way. Does this answer your question?
Yeah, so you could say it's sort of some kind of aggregation or aggregational query, but I guess it's in real time in this case?
Yes. The way projections work in Even is that they are real-time services. They are actors. They keep listening for events. So once you subscribe to some specific events, the service, the projection service, keeps listening for those events in real time and building those states, those aggregations out of those events. And it's important to understand that it's not like just like a list of events. For example, one thing that I will just demonstrate here in a demo is that if you have a list of users that were created in your system, one of the projections may be like all the usernames that were used ever. Imagine you are building, for example, Gmail. Once you create an email on Gmail, you can never use that username again. So they don't have like an users table where they never delete information, because Gmail probably works with some form of event sourcing, I believe. What they can do is that they have somewhere in the system a list of usernames that were already used ever. And so projections can create that list. It doesn't need to be a list of the events that users were created. It may be just some information you can extract from those events.
Yeah, we got another question here from Philip Loriano. Given that event streams are very large, how do you prevent out-of-memory exceptions?
Oh, okay. First, it depends, because the events are actually stored in the database. And I probably should do a demo here because I can show you better how the events are stored in the database. But just to give you an idea, those events are not in memory all the time. Okay, so the idea is that you can have projections in memory, but the projections in memory should be data that you should fit in memory. For example, you should not have the entire list of products, but you could have like the products with discounts, or the products you should show in the homepage, the users that were blocked, or the last sales, the things that you want to cache. So you don't need to store all the information. The information is not stored all the time in memory. It's just what you are using at that moment. Okay. Can I continue?
Yeah.
Okay, so I just wanted to give a background of what I intend to do with that, so people can familiarize with that. I don't work at Google or Netflix, and I don't have a massively distributed problem to solve here, but I deal with a lot of business applications. I work at a software shop, and my life is like most of the developers. We have sales applications or websites that have business logic, and we need to store that in some way. We usually use SQL databases. And one of the problems with SQL databases, or databases in general, even NoSQL, is that the database has a lot of side effects if you change them. So once you have an application that was built like 2 years ago, it's really hard to change the database. The code or the C# project or whatever is easier to change. You could have like a project written in C#2 and you want to upgrade to MVC 5 and use C#6, and you can just create a new project that accesses the same database. But the database is really hard to change, and once you have rules there, it's really difficult to deal with the problems that arise once you start to change. So one of the ideas that I had creating Even, or basically the idea that caused me to create Even, was to start to apply CQRS and event sourcing to organize databases. And the way it would work is that once you store events, you start to project tables that you use as a read-only source for regular applications. So, for example, if you have a website and a backend system, you could just export the tables you need to use your application and use regular Entity Framework or ADO.NET to query this information from the system, because the projections will keep those tables updated, and those tables are not the source of truth. It doesn't matter if they have duplicated data. The source of truth are your events. So you can start to project data to an external system and use that as a read-only source. And to send information to the system, you send a regular Akka message to an actor, to an aggregate, that processes information, stores in the event source, and sends to the projection subsystem again to update the tables. And once you start to do that, you can start using multiple databases. So you don't need to be tied to a single database. You can start to use NoSQL or dedicated stores like Lucent Search or Redis or a DynamoDB or an Azure document storage. And the idea here is that some things are better fit in tables, some things are better fit in a Lucent index. And using Even, you could project information in real time to any of those systems, and you don't care if that information is duplicated, because Even takes care of keeping those projections in sync. And that idea, it can also be used to export information to external services and applications. So even if I want to talk to another system that I didn't create, I could export information at any time. I just create a new projection and I start to export. The projection will read all the information from the streams and start to create that external projection. Another thing that I wanted to do with Even was to build microservices, and the reason is that complex in-memory services are very good to use with event sourcing. Because in-memory services, once they start, you don't want to keep hitting a database all the time. You usually keep the data in memory, but you want to store information. So the idea of using Even with microservices is that you can start an application, and once you start, you read that information and you build your state, the state of the service from the events. And then you just need to persist the changes over time. You don't need to persist every time something happens. But even if you do, the persistence doesn't need to affect your application. You can just like write an event and just believe that it was written. Okay, so microservices was something that I was very interested in using with Even, and some of the ideas there are created to deal with that stuff. Okay. So now I would like to do a basic demo, and I created an application. But before, is there any questions, or am I talking too fast?
There are no questions from the community at this point. One thing that I was wondering, when you're exporting events to, let's say, an external service, what's the durability guarantees on that? Will it try once per event, or will it keep track on what events successfully have been synced to the other service?
Yeah, there are some guarantees. Even itself has only a component that is guaranteed to receive every event in order. So once you receive those events, you can start to send them to a database, for example, a SQL database. What happens is that every time a projection starts, it has a state where it queries that underlying store to know what was the last event that was persistent to that store. And it can just rebuild from there. So it doesn't need to rebuild the entire database all the time. It can just check what was the last event and continue from there, but at the same time you can just truncate the entire table and start over. So the idea of projections is that they are kind of loosely coupled. You shouldn't like create a projection and start to create other tables with foreign keys or stuff, tying to that data, because that data is supposed to be deleted and recreated at any time. Even itself doesn't restart or doesn't truncate your table unless it detects there is something wrong. Every time a projection is created, there is a unique hash that is created for that projection. So if I try to write to a table and that table was created for another projection, it will truncate the table. But otherwise, it will just keep appending the information. And there are some mechanisms that could be applied there, like a hash based on the state of the table. Like every record that is added has like an incremental hash that could be added to the table, but currently I'm not doing that. I played with this idea and I thought it was kind of overkill. It's enough to just have the last position of the projection.
Yeah, we got another question here. Can a projection subscribe to multiple actor event streams, and how does it guarantee event order?
Yeah.
Is that
yeah.
something
Yes. Yes, it can.
Demo or?
Yes. Let me show you the demo here, and I will show how this works, and I will try to explain without going too deep into the code how it works. Okay?
Yep.
Okay. Let me just guarantee here that everything is clean. Okay, so basically I have an web API application here. It's a simple web API application. There is just a single controller where I have a method to get the information out of the system, and this system is basically adding users and changing passwords, and I will get a list of users, like a list of users and passwords. It's just like listing the table here. Okay. Even has a concept of a gateway that you use to send commands and query information, and it's basically just like the master object that you reference to access the event subsystem. If you have the gateway, you can do anything with it. You can write events, send comments to aggregates, and etc. The application here, we have aggregates. Okay, and there's just one aggregate, it's the user. There are events, and there are 3 events here: user created, deleted, and password changed, although I didn't use the deleted here. Okay, so it's just cosmetic here. I have two projections, one that lists the taken usernames and one that creates a table in memory of the list of users and passwords that I can use to check for users. And I have a list of queries here that I do, okay? So basically the way it works is that you send a comment to an aggregate. Projections are started when the system starts, and let me show you here how this is set up. I basically create an Akka system, an actor system here. I set up even with some options. So I have a validator that I will show. Basically, it integrates with Fluent Validation here to do some validation. I call setup even here. I can use options, and there's a lot of options about timeouts and other stuff. But basically what I'm setting here is that I'm using SQL Server to persist those events, and I'm adding two projections to the system. So these projections need to be set when the system starts, but nothing prevents you from scanning a library and adding all projections that match a name or an interface. Okay, so basically once the system starts, projection will start listening to events. I will send comments to the aggregate, to the user aggregate. The user aggregate will persist those events, and after they are persisted, the projections here will receive those events automatically and start building some state. And I will use that state to do some validation in the application. So let me just guarantee that everything's here. And I will run the application again, and then I will just I will go back here and explain some details, okay?
Yep.
Okay, so basically here I'm sending a command here to get the list of users, and you can see there are no users here. This is going to a projection and querying that information. It's a message sent to a projection. And then I will send a command to add an user, and I will add the user full here. And you can see that it was accepted. A command can be accepted or rejected. And one interesting thing here is that if I try to send again, it will be rejected with the reason username is already taken. And I will show how that works. So here I will add another user, and I'm adding the user bar. Okay, and now I will query the system, and you can see that it's retrieving the two users. And you can imagine this in a table. You don't have to use objects. This could be a table. Okay, but basically I'm creating a list of users with the login and a hash that I could use to check the credentials of the user in the system. Now I will try to change the password of someone, and you can see here that I just sent a comment with a specific ID here, and the comment was rejected because the user does not exist. Now, if I query the system and get the ID of this user here and try to change the password, okay, this is the time that the demo gods are not liking me. I noticed that sometimes I have a timeout here, and this is something because it's experimental and there's some checks that I need to do. But basically, what I wanted to show here is that the system is able to detect when something happens in other streams. And this is interesting because one difference between Akka Persistence and even is that even is not tied to a specific string. Once we try to add a user, I will go back here to the controller. And you can see that when I try to add a user, I basically create a new GUID here. And this is the string. When you send a command to an aggregate, basically it takes the class name and the ID that you pass here and creates a string based on this information. The way the string is created is customizable, but the default mode is that it basically gets the name user and it creates a string with this ID and creates like user-GUID. And even though I'm creating a new GUID every time, it's able to check if the user was already created or not. And so I will show here how the user aggregate works. And one thing that you will notice here in the user aggregate, it's basically like an actor, or actually it is an actor, okay? But it has some different handlers here that act like just like the receive actor. But instead of receive, it has an on command where you specify the command that you are expecting and what happens when that command is received. And actors aggregates, they have two things they can do. They can reject or persist an event. And the way that rejection works is that it throws an exception. So basically, once you reject, it stops processing the code. And this was intentional. It was to make it easy to write this kind of logic. Okay, so you can perform some validation here and decide to reject the command directly before persisting. Once the command is persisted, you have another handler that's on event that takes that event after it was persisted to the database, and it processes and updates the state. And one thing you'll notice here is that I'm not persisting the username or password. I'm just persisting information that is related to the aggregate. And this was something that I realized when I was working with more ways to write events to the database. Since not everything is an aggregate, and you have projections, aggregates don't need to keep the entire state of the string you are working with. So basically, to accept comments to this aggregate, all I need to worry here is if the aggregate was already created or it was deleted. And this is enough. But you notice that the information to reject the user, if the username was taken, is not here. And the reason for that is that I have an integration with Fluent Validation. And for those that don't know, Fluent Validation is a very popular library to validate objects in ASP.NET or any other .NET application, where you can create validator classes with rules and any kind of rule that you want. And you notice that basically I have here the rule where I query the gateway, and I send a query checking if the username is taken. And this query will go to a projection that is listening to this information, to this query, and will answer true or false for me. The projection in case is the taken usernames projection. It's also an actor, and it's very simple. It basically listens to all the events user created and adds to a hash set here. And when I receive the query, it subscribes to this. It uses event strings to subscribe. So basically, all the queries are sent to the event string, and whoever listens to these events, to this query, can answer. And this query checks the hash set to see if the username is here and replies to the sender. So I have the validator for this command that can go to any part of the system and check for information before accepting the command. This validation may happen in the aggregate, but it may also happen in any external component. And this validation is nothing that is fixed to the even framework. In fact, I created a small validator here. You basically implement this command validator interface, and you can call any method you want to apply the validation. It will return an object called reject reasons with a dictionary of validation errors. And this is generic enough that you can use any kind of validation framework, even like attribute validation, to validate comments. Okay.
Is the projection guaranteed to be in sync with all the events when you send the query, or could it be if two requests try to create the same user at the same time? Could you get the race condition saying that it's okay to create the user, but the event for the creation of the first user had just not been processed by the projection, so to say?
Yeah, this could happen, but there are simple ways to deal with that. First, because because projections are Akka actors, they have a queue. So if I create, if I'm using the same actor or the same aggregate to check for something, they will send the events, the questions to the projection. The projection will process them in order. Okay, so sometimes, even though this happens, the queue system of Akka will protect some of these things from happening at the same time. Now, if you have different aggregates, you need some other mechanisms to check for that. But it's not very complicated to add. For example, you can have in the aggregate a simple object like a static cache to check for usernames used in the last 5 minutes or so. And this is something that I plan to add to even. There's a lot of ideas about how to cache information inside actors that can be applied to the situations and avoid some of the problems of eventually consistent systems.
Yeah, we had another question from Philip Loriano. Aren't you bottlenecked by the underlying data source? For example, if you have 1 million actors at once and you have one massive event stream, how do you pull in enough events without taking down the data store?
Yeah, this is an interesting thing about event stores. Yes, you are kind of limited by the underlying data store, but the data store is like a write-only database. So when you persist an event to the database, you don't need to read that event back. The way it even works is that it sends the information to the database, and once the database confirms that that is written, it just sends the same objects that you use to persist, it sends them through the event stream to all the projections. And because of that, even though you have a lot of events being written, the database is focused on writing on a single table. And there are some mechanisms inside even to write lots of events. For example, if you are just writing events like tracking, imagine you are just receiving events like someone clicked on a link, and you have a bunch of those events. Those events are not, they don't require specific ordering, and the way that they are written are not through aggregates. They are written using just a method like write event. And when events are written like that, they can be buffered and sent in batches to the database. And that's actually what I do. So basically, the system gets a bunch of events, like 500, 1,000 events at a time, and sends a single command to the database. And it's very easy to do that because since the data store has a single table, it's very easy to check for all the information and make sure that all the information fits in the tables. The only thing that is variable in this table is the event payload. And the table is created to have, like, if it's SQL Server, it's a var binary of max. So you can store like a gig of information there. So it's very easy to optimize the writes, and the system doesn't need to read the information while the system is running. The system only reads information when it's restarted. And this creates this interesting advantage that even though you have a bottleneck, it's probably not going to be a bottleneck during runtime because you don't need to keep reading and writing. The server is only doing one thing, and it's doing that thing very well.
Yeah, I think that answers Philip's next question. He wrote another one. I'm more concerned about the reads. What about 1 million reads at once? But that wouldn't really hit the data store at all. That would hit the aggregates or the projections, right?
Yes, there are some interesting things that we can do with Akka because since we are dealing with messages, once the writer subsystem receives a message, it can decide if it needs to write that message right now, if someone is waiting for that message, like an aggregate needs to wait for messages to continue, but if you're writing from a command processor where you are just checking for some information, applying some logic, and sending sending the event to the database, that event doesn't need to reply with that information back. Only projections will use that information. So the writer subsystem can do very clever tricks, and we are not doing this right now, but for example, we could use bulk insert from SQL Server to write events. I did some tests with MySQL a few months ago, and MySQL, for example, can write about 100,000 records per second in a single table if you write them in a specific way. Right? So depending on the database, this needs optimization. SQL Server is very good if you use the bulk insert method. MySQL is very good if you create a single string and send it at once with multiple values for the same insert. And other databases are very good if they use parameters. So it depends on the driver, but this can be optimized to make it simple to write a lot of data to the database. Okay. One thing that I want to show here, because I think I'm out of time, I'm talking a lot here, sorry. I just want to show how projections work for multiple streams. So when you create a projection is basically a class that extends the projection class, and this is an actor. You call a bunch of handlers on events, and you subscribe to these events. These events don't need, they are not tied to any string. You don't specify strings here, just say the events that you want, and these events may happen anywhere. And the way this works is that when the actor starts, it sends the list of events that it needs to another system called projection streams. The projection streams analyzes the events that it needs, and it creates a hash based on those events. And even if multiple projections subscribe to events in different orders, they will create the same hash, and because of that, they will go to the same projection stream. And the projection stream is a different actor that is responsible for connecting to the database and reading those events in order and sending those events to the projection subscriber. So it's not like this actor itself goes to the database. Actually, there is another actor called the reader, and this projection goes to the projection string system that aggregates many projections into a single string. And that projection goes to the reader to ask for data from the database, or it subscribes to the event string to get data over time. So when the projection starts, it goes to the projection string. The projection string queries the database, reads all the information at once from the database, and sends to all the projections. And once it finishes replaying those events, it subscribes to the event string and starts reading events on real time. So projections are kept in sync. If you restart the system, everything just magically works. One thing that I'm not showing here is how to project this information for external databases, but the idea is very similar to this. If you can see here that once this logging list, and the logging list is the list of logins with login and password that I'm showing in the application. Every time a user is created, I create an entry in this object, but I could also send this information to a database and do an insert or update. And in fact, what I'm doing in a branch is that I'm trying to come up with a standard way to project this information to a database. And the way this would work is that you would declare here or override. I will write here just, it will cause a lot of errors, but don't mind. You could write something like this, an external projection, and say it's what's the connection string and the table name. And you could write here project based on the ID. So I could get the string name is the ID, like the primary key on the table, and then I will just create an object with the information like username and password. And this is something that I'm working on. So instead of storing this information in an object, this kind of projection would start sending this information to the database based on this object here that you define. It could be a Postgre, a MongoDB, or anything that you want. And the project method will take care of checking if that information is already on the database and merging information if needed. So even if you have multiple columns here, and I'm projecting only 2 or 3 of them, it would always be a merge on the database. And this way, when you receive an user change event, you could simply project based on the string name the new password hash, and it would merge this information in the table. This is something that it's still in a branch, and it needs more work, but that's the idea of how you would project information to external tables.
We do have 2 questions. I think we have to let Bartek in soon.
Yeah.
About,
sorry.
Cluster.Sharding, but there's a question on where is the source code for this example? Is it on GitHub?
Not yet, but I will publish there, and I will post a link on the Gitter chat, and probably Aaron can put that in the YouTube comments.
Yeah, we can put the links on the Hangout comment sections. And there's another question about if I change the definition for an existing projection, how would I rebuild this projection?
There is a method here called get.LastOnState. The task of this method is to go to the underlying database and get the hash of the string and the last sequence number of the event. So the idea is that every time you project this information to a table, you need to store this information, the hash and the sequence number of the event. And once you have that, you can just go to the database and get the max from the database. And I will use this information to just send the next events from the string. Let me just show here very quickly. The system is comprised of 3 tables: the events table, the projection index, and the projection checkpoint. One thing that happens when you create a projection is that it's indexed on a specific table here. And it has a sequence, so you can know the sequence of that event inside the projection. In this case, both projections are listening to similar events, so they will create the same sequences. But the idea here is that every time a projection listens to an event, they will index this table. I can truncate this table at any time. It will be rebuilt. Every time the projection starts, it goes to this table, checks if there is anything here. If there is nothing here, it will go to the global string, and that's what I call the list of all events in the application. And it will start reading those events, filtering them out, and indexing them. So if you have 1 million events, and you only use some of them, they will be indexed, and this will be used when the application is restarted. So I don't have to query the entire stream again. So this is just to give you an idea about how this information is stored. Okay?
Yep.
Okay, so I think that's it.
Other questions on the events part? Maybe there are more questions during while Bartek talking, so we can follow up that.
Yeah, sure.
After that. So next speaker is Bartek. He's going to talk about cluster sharding.
Hello, do you hear me?
And let's see if I can make Bartek the presenter. Yeah, you should have the presentation now, Bartek.
Okay. So can you hear it? Can you see it?
Yeah. We can't see anything from you yet.
Okay. Wait a second. How about now?
Nope.
Oh. I see that I'm sharing my screen with others, but I only see black screen on my lower right, minimized view. Oh no, this is really bad. Okay, this should be. You can see it now.
Yep.
Okay. So my presentation is about Akka.Cluster.Sharding, and this is one of the, I would say, base modules of the Akka project. Is all supported from the JVM version of Akka. And what it's about, one of the major goals here are way to create. Sorry, can you hear me?
Yeah.
Okay. So the major goals here are, we would like to have a way to communicate with our actors without necessity of creating them, having to know their exact location and so on, because basic, the most baseline level of Akka actors is quite low when you have this iActor ref, which you are using to communicate with some actor. But in the cluster scenarios, you actually need also to know the location of an actor on which node does it live, or for example, if the node goes down, then we need to recreate that actor on some another node and recover the actor ref for it again. And one of the major goals of Akka.Cluster.Sharding is to, make this transient for us as programmers. And what we want to have here is a way to communicate with actor and ability to create them as well when necessary, without having the actor ref, without having the exact node address they should be created on, and also to balance them across all cluster nodes when necessary, without programmers' ignorance. So we like to have all of this happen behind the scenes. And I would like to start with the demo, and are there some questions about this?
There's one question asking what ingerence means.
Sorry, what?
Without user ingerence.
Sorry, this is
word.
This is my mistake. I meant the user, interfering in the executing code. So what we need to actually create a cluster sharded actors. Here we have few major concepts. One of them is that usually when talking about actors managed this way, we don't refer to them as actors. We would rather refer to them as entities. Entities are created and managed by so-called shards. If you are familiar with Azure Service Fabric, I think it's a similar level, similar conceptual level to what Azure Service Fabric partitions are. And good thing.
Can you change the font size on the code, because depending on the video quality, it's too small for some people.
Of course. How about now?
Yeah, much better.
Oh, okay. So this is one of the examples from the core Akka repository. Good thing here is that we can use cluster sharding on any kind of actor we'd like to, so we don't need to inherit from some specific kind of actor. The only thing that is needed sometimes is needed by the actors managed by shards is passivation, knowledge about passivation, but I will talk about this later on. So here for this example, we'll have simple printer actor, which will basically print the received message on the console, and actually also showing its own path, because this will make explaining things later easier. Also, what we have here is a class called env, and this is an envelope message that we are using for cluster sharding. Here is a kind of wrapper around the message we would like actually pass to the actor. And here we have three fields, which is shard ID, entity ID, and message. Entity ID is correlated with the name of actor itself, where the shard ID is the name of its parent. And basically this tuple of shard ID and entity ID allows us to uniquely identify the actor across the whole cluster. Also, what we need here is so-called message extractor. Message extractor is a class which defines a logic used to extract entity ID, message, shard ID, and message itself from basically any kind of message in context of cluster sharding. So as you can see, we don't have a predefined message type here. Instead, we can adjust it to our needs. Good thing
so this class is used to extract the user message from the envelope, and the envelope is also a custom message for the.
Yeah.
Okay.
Yeah. Exactly. All of these are custom messages, and we can we can apply different scenarios here. We can create, for example, message extractor using some kind of interface implemented by message or something like that. Good thing is that it needs to be defined once for whole cluster, and maybe not so good thing that it needs to be exactly the same for all cluster shards, because it's used for the whole cluster. Then what we also have here, this is a simple configuration. I'm using a wire serializer here. I'm creating a cluster for Akka, and also I'm using SQLite persistence for this example, because cluster sharding relies on Akka persistence, and few components that I will be talking about later are using persistence for coordinating the state of the whole state of all cluster shards inside the cluster. So what we are creating here, automatic cluster join is some kind of a magic I've created for the sake of this example. So I'm not building a cluster based on the lighthouse here, or neither I'm creating any kind of seed node here, because we already have SQLite in this example. I'm using it to also pass the information about current cluster state in terms of members actually active in the scope of this cluster. So here in this example, what we have to give a cluster node, a single actor system ability to communicate or use the cluster sharding, we just need to define this cluster sharding get extension. This is a standard extension system, and it will return extension object, which we can use to instantiate so-called shard region. Shard region is a special kind of actor, which is it's always a single kind of actor of this type per node. So we have as many of them as nodes in our cluster. And moreover, it's also a single actor per node and per type of sharded entity we want to use. In this case, it's a printer. Then we also have some settings here. These are mostly default ones, and also a message extractor itself to inform how to extract the necessary information for that are needed for by cluster sharding. Any questions here?
No questions so far on.
Okay. So I've also created a simple code that will randomly create some messages and send it to random entities in the cluster. So let's start. I will start by creating 2 cluster nodes. Here's the first one. It's actually logging on the info level, so we have lots of messy informations that are not necessary here. As you can see, the second node has joined. And in this example, I will just order second node to produce messages. And I want you to look exactly what will be happening here.
Zoom in a little bit on those windows, because I think those will be.
Okay, so we have one here, and we have one here. Okay?
Yep.
So what you can see here, we have a second node which is producing messages, only second node. However, the printer actors are receiving messages both on the first and second node. You can also see the actor path. The last 2 numbers are actually a shard ID and entity ID of the actor. Before that, we have a shard region, which is printer for this case. And as you can see, we have single node emitting messages. However, on demand, we are creating actors which are balanced across the shards on the both nodes. Now let's create a third node. Hopefully there are still some non-allocated shards. Okay, hopefully, because I've created only 20 shards here. There are only 20 of them allowed. If I would, oh no. Oh, yes, so as you can see, we have also the third node which have some shard on it too. There is a possibility of handing over shards from the mostly occupied nodes to the less occupied ones as the new nodes are coming to the cluster. However, this is something that is configured by the threshold, because not in all cases, is fruitful to rebalance shards from the existing node to the new node, which have free resources, because the cost of the rebalancing itself could be higher than potential gain from this kind of operation. Okay, so now these are standard cluster errors, and also just like we have rebalancing caused by the handing over, we have also another kind of rebalancing, which is taking over. It's applied in the case when you have some nodes which have gone down for some reason, and then in that case cluster sharding is recreating shards which were on those nodes across the living nodes inside the cluster. Okay.
So just to be clear, one shard is sort of an abstraction that contains some entities, and there can be many shards on the same node.
Yeah. So the basic notation here is that we have managed actor, so-called entity. Entities are never managed one by one, because this would be too expensive to rebalance entities one by one here. Instead, they are managed in groups, so-called shards. And again, there can be many shards inside the single cluster node, and they are managed by so-called shard regions. And shard region is an actor which is responsible for managing all shards on the single node. I want to go to some technical overview if you want, to describe this a little better.
Yeah, there's a question about how does balancing between shards work? Does a single entity always belong to the same shard, or can the entities move between shards also?
No, the same entity always belongs to the same shard. This one of the rules that we have to fulfill here.
Okay, so there's really no rebalancing on shard level, on the contents of the shard. You could have unbalanced shards.
When rebalancing occurs, we are rebalancing whole shards, not the single entities. So yeah. Because this is related to the problem of creating a good sharding algorithm. Because in many cases, we can, for example, use natural context boundaries for domains of our application, like office names. And for example, we have office name which is shard ID, or some kind of provinces, regions, something like that. However, this might cause uneven distribution of entities in that case, because some shards might have more entities than others. I know about two ways that we can utilize here. One is to, for example, we have a shard representing a big province, big country, for example, and another one which is representing a small. So we could adjust this algorithm to basically split the bigger country, bigger region into a few smaller pieces. And another kind of sharding algorithm is based on mathematical kind of distribution. When we have, for example, some kind of entity which we will take hash from and basically split it by the total number of shards we are expecting to handle in our application.
Yeah.
There is a rule of thumb I've heard from the TypeSafe guys, the original authors of Akka.Cluster.Sharding from JVM, now called Lightband, that we should have, like, for example, 10 times more shards expected than the maximal number of nodes we have on the cluster. So right now I want to show how all of this works underneath. So maybe you have some questions before I start.
Yeah, there's a question here. When rebalancing occurs, is actor state preserved?
No, this is something that needs to be taken care of by user or by using things like event framework we were talking about today, or Akka Persistence itself. Also, in case when you, for example, use the think that Akka Persistence is overkill, then in pre-start or post-stop events of lifecycle events of actor itself, you could just save the state in the database and recover it basically on the pre-start when you are when the shard is rebalanced on another node. There is also this is also associated with passivation, and as I said, I will come back to this later on. Okay, something more?
What is that?
Any more questions?
No, not at this moment.
Okay. So in this example, we have two nodes. This big circle is shard region. Smaller circles are shards, and the smallest ones, blue ones, are entities itself and themselves. We have also something that is called coordinator, and coordinator is a singleton. It's a cluster singleton. There is only one instance of this actor in the whole cluster. And coordinator is a top-level actor, which basically orchestrates the way all shard regions are, communicating together. So in this example, we have two nodes, both with two shards, and we have user, some kind of user code, and let's say that this user wants to send a message to shard 5 and entity 1. As we can see, there is no such shard or entity in current context. Also, current shard region doesn't know about this shard anywhere in the cluster. So what it does, shard region will ask a coordinator about the possible location of this shard. This is one of the things that coordinator is required for. Then coordinator will allocate, of course, in the case when the shard was not found, then the coordinator will allocate the shard of one of the shard regions, so on one of the nodes. This is a customizable option. It's called allocation strategy, and by default it will choose the node which has a least number of shards, not entities but shards. So next one, we'll create this shard. Shard will inform shard region that it has been initialized, and at this moment shard region will cache information about shard region which handles this shard. So this shard region on node 2 will cache information that shard 5 is placed on the shard region on node 1. And then it will forward this message using not the shard itself, because it can be moving, but instead shard region from node 2 will pass this message to shard region from node 1, and then it will be forwarded to entity on shard 5 itself. And all subsequent messages sent to that shard are forwarded are forwarded directly without using coordinator, because at this point it's not necessary anymore.
There's a question right now from Philippe Loriano again. How is sharding any better than persisting state to a strongly consistent data store?
Actually, shard itself is shard coordinator, and also shard are using Akka Persistence to store their actual state in the database. However, these two things are not quite related, because here we are not talking about storing some state, but we want to handle in the case when we don't want to care about even distribution of actors and shards, more shards in this context, and to recreate them or rebalance them, handle the node failures. And for this case also, what is important, it's faster than using a database. It's a lot faster.
So it's more about resource allocation than anything else, right?
Yeah, basically, if we call actor a resource.
Yeah.
Anything more?
Nothing more right now.
Okay, so just a quick info how rebalancing works. So let's say we have node number 3, which wants to join the cluster. Once it's done, coordinator starts a handoff procedure. So it sends a special kind of message to all shard regions, so also all nodes, to clear the information about presence of shard 5, because during the allocation strategy it turned out that coordinator decided that shard 5 will be rebalanced on node 3. So right now it's sending messages to all of nodes, so they should clear information about rebalanced shards. In this case, basically all of the nodes have no have no information about where the shard 5 lives. In this case, all messages that are passed to that shard are cached on each of the nodes until the presence of this shard will be known again. This also happens in other kinds of scenarios when we have subsequent messages going to shard that doesn't exist yet. Each shard region will then cache the message incoming to that shard and redeliver them later on when the shard location will be known. Then all nodes will acknowledge this message the coordinator. Then it will send a handoff message to the node that is currently home for this shard. And this node will destroy shard actor responsible for handling the shard, and inform about this fact coordinator itself. Then just coordinator will just send a host shard request to a new shard region, and this shard region will recreate the shard. And important thing here, I think it's important, is that we have two modes of recreating shards on the with the entities on each of the nodes. First one, which is default, is that shard is recreated, but its entities are not. So we have, three resources here in this case. However, all messages, this entity actors on the chart are no longer living. So they will be created ad hoc when necessary, when new message will come to them. However, I think that this might be a little frustrating in case, for example, we have some kind of scheduled message, and there is a second mode which is configurable, and it's called remember entities. And by using it, we tell target shard that when it's recreated, it should also recreate immediately all entities that were living at the moment when the rebalancing started. So this is an important note here. Also, there are two more things I want to talk about. First one is passivation, because right now, since actor can be rebalanced, it also can be stopped by the shard. However, in this example, when you have shard actor entities which want to, for example, stop after they are not used for some time, we need to manually create a set receiver timeout and not stopping the entity itself. Because in this case, when we are stopping entity, there may be still some messages that are coming to that entity when it's stopping, and we don't like to missing all those messages that were not delivered, because in this case we would have messages sent to dead letters. So in this case, we have a special procedure which is called passivation. And in this case, when we, for example, would like to have actors with state or without state, which we would like to destroy after some period of inactivity, you could do this like following. Receive timeout. And here, as we maybe remember from the demo a while ago, each entity can refer to shard as its parent. So in this case, we would like to send a special kind of passivate message to that shard. And what it does, sorry, forgot to tell. Okay, so what does it do? What you have here, it's sending a message to shard from inside the entity that current entity is going to stop itself. In this case, the shard will start to buffer all messages incoming to that particular entity, and when it will receive this passivation message and apply that logic, it will send so-called stop message to to entity itself. In this case, it's poison pill, which will cause an actor to stop. It can be also customized message, because in some cases, especially for event source scenarios, you might like to have our custom logic defined. So this is something called passivation, when we have entity informing its shard, which it lives in, about about that it's going to stop itself in the future. Also, some questions here?
No, not right now.
Okay, so this is about passivation. Oh no, I forgot about the second thing. So I think I will stop here for now. Oh, I remember what I wanted to show here, because the example at the present moment doesn't show that option. There is ability to query cluster sharding about some statistics on the state of each nodes. And here we have shard region, which we could ask with the get shard region state and get shard region stats message. Okay. Oh, sorry, I forgot that this is a single. Okay, and what we will get in return is shard region stats or shard region state message in response. And sorry, result. Okay, because ask always return a task. So what we have here, shard region stats will return a dictionary of string and int, where string is a shard ID, because we might define them as ints, grids, any kind of type we like, but cluster sharding will always refer to them as strings in case of both shard IDs and entity IDs. So what stats does, it's a dictionary having a shard key and number of entities living on that shard. This is a kind of statistic we can ask cluster sharding for. And this only touches a current node. So if you would like to send it to all the nodes, we could use things like, for example, basically cluster shard region is always exists under the same path on each node, so we could use actor selection in that case. What get shard region state does. Whoa. Okay, so I will just go here. Wait a second. Oh no. Sorry, my bad. But what it should do in this case is a similar dictionary. However, instead of having a number of entities, we would like to have a list of actor refs for all the entities in that particular shard. And this was the last thing I wanted to present.
Okay, so you could use that for some sort of monitoring system, or what's the main idea behind those sharding query systems?
Yes, exactly. You can use it for monitoring, for making some timeline statistics, or the name stats itself is describing, I think, the goal here.
Yeah. Another question I have on this part, because this is obviously touching the same kind of problems that Azure Service Fabric actors and the Project Orleans also deal with the virtual actor concept.
Yeah.
What would you say are the pros and cons of the different solutions to this problem?
First of all, this is modular. So we are not bounding the whole of Akka toolkit for this single implementation. If you don't like the way it's working right now, you could just replace it. Another one is, like, I think that all modules in Akka toolkit, it's that it's not designed to be end case scenario. So it's basically created for cases when you want to have some easier way to doing things, but you also want to apply your own abstraction on top of it, which you could use for exactly the case you want to solve. And as you've seen here, we have the notion of shards. So it's I think it's a closer conceptually to Azure Service Fabric than to ordinals themselves. Also, this is actually nothing new, because the Erlang solution also has so-called React Core, which is providing basically a very, very similar solution for Erlang actors. So, automatically manage the actors based on the shards.
Yeah, I don't think we have any more questions, or at least I can't see any more questions coming in here. We have been running over for quite a bit, 30 minutes late, so I guess some people might have dropped off during
Okay.
the presentation. Yeah, so if there are no more questions, I think we'll call it for today. And thanks to Bartek and Natan for presenting today. And we will try to put the links to even on the comment section on the Hangout, and same for the examples on the cluster sharding stuff. So with that said, see you next month. We don't have any date set yet, but I guess it will be at the end of March if everyone is able to attend then. So thank you for today.
Thanks. You.
Sorry.